Assalamualaikum, and hopefully you all in good conditions. Okay, life cycle costing calculation. So I will show you the how to calculate and estimate life cycle costing. The life cycle cost of an asset can be expressed by the simple formula. It is called life cycle costing. Is capital cost plus lifetime operation cost plus lifetime maintenance cost plus disposal cost and minus residual value. However, ascertaining a measure of each variable in the formula can be difficult, for the costs are usually subject to level of uncertainty that arise from a variety of factors, including the prediction of pattern of use, the asset over time, the nature and scale of operating costs, the needs for and cost of maintenance activities, the impact of inflation on individual aggregate costs, the prediction of the length of the assets use life, and the significance of future expenditure compared with present day expenditure. The longer the period involved, the more difficult is to estimate future costs. The reality, however, is that it is often unnecessary at the outset to estimate costs beyond 15 to 20 years. In fact, many items of equipment have a useful life of less than 20 years. Even for items with very long life, that process of discounting future cost means that the cost beyond 20 years generally have only a small impact on the life cycle cost model. Calculation of life cycle cost can be assisted by the use of cost model that use sophisticated algorithm to reflect the impact of different assumptions. The models are normally implemented as computer programs which enable many different scenarios to be investigated without adding significantly to the time and effort. With this model, a manager can focus on the implications of the analysis for decision making rather than just on the process of calculating the cost. Cost element: to estimate the total life cycle cost of an asset, it is necessary to identify the key cost elements. The choice of an appropriate set of elements will reflect three specific issues. The element must be clearly defined activity that generate costs. As far as possible, elements should be independent. The timeline for the element cost must be known. The significance of cost generally depends on its position in time within the life of the asset. And the third one, the relation between the resources used by element and resulting cost must be known. Change in market condition and price movement are more easily reflected through cost change in specific resources type. Means that we need to identify the LCC for individual. For example, we want to calculate for the lift or for the genset in the building, so that we need to calculate individually. Okay, for genset separate item, and for lift also separate item. All right, and then photocopies and printer, for example, plant and vehicles. There is functions, engine capacity type, driving mechanism. This one is we want to compare either which model we want to buy or which spec we want to buy or install in the building. Okay, for the building, we need to calculate on the locations, land, stormwater, sewerage activity, main structure, roof, external fabric, interior fit out, door and windows, and others. The process of modeling the life cycle cost of an asset does not make any allowance for depreciation charges that are part of an organization profit and loss statement because the full capital cost is already included in the model. If depreciation were also included, this will effectively be double counting the capital cost. So number one, we have the net present value when an organization have a choice of incurring a cost now or in the future. It can generally consider the benefit of alternative use for the available fund and the cost of raising the necessary funds. Future costs are regarded as less significant because they have the potential to be funded by effective use of existing funds over the intervening period. For example, if $100 purchase is to be made today, it is necessary to have 100 available now. Means that we need to have a cash now. However, if purchase can occur in 3 years time for $100, it will be possible to generate the required $100 by investing $75.1, $75.01, 10 cent at an interest rate of 10% for the 3 years. If the fund can be used in some others way by the organization, it may be able to generate more than 10% per year, which would makes the future cost even more attractive. In a similar way, the value of a payment to be received at the future time is regarded as less than the value of receiving it now. In order to quantify the time impact on future receipts and costs, this cash flow are converted to an equivalent present value. How to calculate the present value? This conversion is based on estimate discount rate R and use the formula. Present value PV equal to FV means that FV the amount to be spent or received at the point in the future divide by 1 plus R. 1 plus R is the discount rate applicable to the chosen interval, and the numbers of interval between the present and the future transactions means the year. Okay, and then the power nominated, the symbol of power, so mean FV divided by 1 plus R power n. Simple calculation NPV and expenses of $100 in 3 years time with a discount rate 10% would have a present value PV of 100 divided by 1 plus 0.1 is 10% power 3. So means that we have about $75.10. The net present value is simply the difference between the present value of future revenue and the present value of future costs for an activity over a given period. Okay, so life cycle costing estimating. Basically, we have 5 indicator estimating analysis in LCC. Number one, net present value (NPV). Number two, amount of RM1 table A, and then amount of RM1 per annum table PV, annual sinking fund SF, and then number five, present value of RM per annum or year purchase table method of valuation. Means that, for example, we saving RM 1 ringgit every year. So we can know for the next 20 years how much we can get if we have the interest for that, or dividend, we call that the dividend profit from the saving. For example, you keep your money in the what we call that, the ASB. Okay, after 10 years, okay, every year you keep your money about $100, 100 ringgit. So in the 10 years you can calculate how much you can get the profits. Okay, the PV formula is that CO, cash flow today, time by 1 plus I. So I mean is interest rate. Okay, this formula for the present value of $1, 1 ringgit, show how much should be invested today to get the value of RM1 at the end of the year, of end year. Okay, how long you want to get your money. For example, you want 93,500 for next few years. For this one, this no end, so means that the for the a year, for 1 year only. Okay, yield and the cost development. Suatu rancangan kos tidak dapat diperoleh secara tepat, hampir tepat, tanpa pertimbangan jumlah kos keseluruhan, iaitu kawalan, kos awalan, initial cost, and kos hadapan, future cost. Cost issue terlibat yang dihuraikan dalam angka-angka ialah pertimbangan dalam perkara berikut: discounting future payment, life of building, the relationship of design and maintenance, and life cycle costing. Competency party is valuer that can value the price, or the value of the building, okay, building value, okay, to know the have to analyze and determine future cost value of building through net income. Okay, total tools calculation is important the engineer to know and determine economic analysis in order to assess the real cost of using resources when establishment. For example, we have initial cost and future cost, including the maintenance. Okay, this is a sample for calculation. Nilai kini 1 RM1 menunjukkan jumlah yang patut dilaburkan hari ini untuk mendapatkan RM1 di akhir N tahun dengan kadar faedah I persen setahun. Okey. Contohnya kita letak 1,000 dengan nilai faedah 8%. So selama 10 tahun kita akan dapat 10,800. Okey. Itu sebagai contoh lah. 1,000 setahun. Jadi profit dia lebih kurang 800. Okay, amount of RM1 table definition. Total capital at the end of period of end year if invested at an interest rate rate I percent per annum in the initial year. Angka daripada CV ialah jumlah modal terkumpul di akhir jangka masa N yang dilaburkan dengan kadar faedah I persen di awal tahun pertama. Ini mana RM1 dilaburkan pada awal tahun telah menjadi RM1 plus I, means interest, power kuasa 3, okay, 3 tahun di akhir tahun pertama. Okay, ini adalah contoh calculation dia. Okay, yang ini per annum, PV equal to 1 divided by A. So apa masuk A? A adalah 1 tambah I kuasa N. Okay, itu adalah formula bagi A. Okay, annual sinking fund, CV sinking fund memberi jumlah yang patut dilabur tiap-tiap tahun dengan kadar faedah I%, setahun untuk mendapatkan RM modal di dalam jangka masa N tahun. Okay, jadi ini kita nak kumpulkan duit lah. Berapa banyak kita nak. Okay, present value of RM1 per annum of year purchase. Okay, YP. Okay, this example of YP, 1 divided by 1 per A, and then 1 minus 1 per A and divide by 1. Okay, dia sample calculation for your tutorial. So I show you how to calculate the number 1, the sample. Okay, we see the initial cost is initial cost RM 23,000. Then the maintenance every 5 years. Okay, maintenance every 5 years. Sorry, every 4 years. 4 years. Okay, 4,500. Okay. So how to calculate this maintenance? I'll show you later. And then renewal every 20 years. Renewal every 20 years. How much? 20,000. Okay. So general repair for the type B, I show you the how to calculate for the type A only. Expected life of building 60 years means that this maintenance every 4 years. So you must calculate number 1, maintenance. Number 1 for the first 4 years. 4 years means PV equal to, we look at the formula, we use this formula, PV equal to 1 divided by A. A means 1 plus I power N. 1 plus I power N. Sorry. Okay. So for the 4 years, PV equal to 1 divided by 1 plus I, how much? Sorry. I, this 8.5. 8.5% per annum. Okay, so we use 0.085%, 0.05 power N. N is 4 years. Okay, so equal to use calculator. Okay, 1 plus 0.085 power, sorry, this one power 2. Scientific calculator. Okay. Okay, 1 divide, sorry, 1.085 power 4. Okay, 1.385, 1.386. Okay, 1 divide 1.386, 0.722, 0.722. 0.7. Okay, number 2 for the 8 years. Okay, same also, 1 divide by 1 plus 0.085 and power 8. Okay, so 8 years. Huh? Okay, and then you calculate, got the answer here. Okay, so after 8 plus 4, another 4 years, 12 years, and then 16 years, and then 20 years, and then 24 years, and then 26, 28 years, 32 years. So you calculate until the 60 years. Okay, for example, we next until the 60 years. Okay, and then you plus all this answer. Okay, for example, okay, the answer PV, all PV equal to 0. 0.722 plus, for example, the next 8 years is 0.621 plus for the 12th year, for example, 0.555. Okay, and then you got all the PV. So the answer of the PV, for example, 0.722 plus 0.621 plus 0.555. Okay, so you got the 922.227, and then you time with the maintenance cost for every 4 years is 4,500. Okay, equal to time 4,500. Okay, 2,800,2.8 million, 246.5. Okay, so this value to be paid for the 60 years of the life of building. Okay, same also goes to the renewable energy. Okay, for the renewable energy, renewal every 20 years. Renewal every 20 years. So mean we start with 20 years. Okay, and then 40 years, and then 60 years. Okay, so you calculate the PV, and then you sum all the PV and then time with the value of the renewal every 20 years. Okay, and then you, after that, you got the all calculation, and then you plus the initial cost, and then you can get the cost for the type A, and then after that you calculate for the type B. You compare which one is a good choice of the building, for example. Also, example number two, for the cladding of to a factory building. This one also you can calculate which one is better for the to choose for installation for your factory. Okay, and then question number three, you more or less same with the question number one. Okay, and then this assignment for you to do by individually. Okay, and then submit next week for this assignment, and then the tutorial you can submit by tomorrow. All right, thank you very much. If you have any question, you can ask me later in the comment or in the group. Thank you. Assalamualaikum.